Hello, hello. So we're going over our functions and relations guided notes. So let's first hit on some vocabulary. So a relation can be represented by a set of ordered pairs. The domain is the set of all inputs, and the range is the set of all outputs. The independent variable is the same as the x values and the input. The dependent variable is the same as the y values and the output. A relation is a function if for each x value there is exactly one y value. Each value in the domain of a function is called an input, and the corresponding value for the range is called an output. All right, so what we're focusing on today is how to determine if what is given to us is a function. So we have relations here, which are our ordered pairs. So we need to make sure that we only see -2 once. We only see 0 once. We only see 4 once. We only see -2 once. Ooh, all right. So I have already recognized that I'm looking at my x values, and I'm making sure that every time I see -2, it should show me 0. But over here, it says that my x value, -2, can also give me -1. So this would not be a function, but our domains are -2, 0, and 4, where my ranges are 0, 3, -7, and -1. Now, another way we can tell this is a function is because we have less numbers in our domain than we do have in our range. All right, so not a function. All right, here it's set up in a table for us. So rather than having to pick apart, I've already got all my x's up here. I've got -4, -1, 2, and 3. None of them repeat. On range, I've got 1, -5, 8, and 1. And up here where I put each value in a domain of a function is called an input. Our input is our x values. Our output is our y values. Okay, and here, -4 only goes to 1, -1 only goes to -5. I don't see a repeated x value, so I know this is a function. All right. Down here. I have -5, 0, 0, and 3 is my x values. 0 repeats, so it is not a function. I'm just going to put no. I got 2, 6, 1, and -1. No repeats. That is a function. -1, 0, 3, and 3. Oh, not a function. All right. It says explain why or why not. The important thing to remember is a function means that the x values only have one output. So every input only has one output. So where I say see 3 here, I see 3 twice and it's got a different output each time, which means it cannot be a function. Now that does not mean that our outputs can't be the same, just our inputs can't be the same. When given a graph or picture of a relation and asked if it's a function, the vertical line test is used. This test helps you know a relation is a function by looking to see if any vertical line drawn does not intersect the graph at more than one point. In other words, on the graph, Each x value is paired with only one y value. So in order to test this, you go, it's easiest if we go ahead and get a ruler, and we draw a line through each point on our graph. They only run into one point on the graph each, which means this is a function. That is a vertical line test. So let's go over here. I got one here. Uh-oh. 2 points hit this one vertical line, which means this cannot be a function. All right, looking at this one again. This one hits in a lot of places. This is definitely not a function. Over here, this one looks kind of sketch. Let's test it. Oh. Where I'm drawing my vertical lines only hit on 1 point on each part of the graph. So this is a function. All right. So if ever you're given a graph and you need to figure out if it's a function or not, all you have to do is get out your handy dandy ruler and double check. Does anything hit in the same place when I draw a vertical line up and down? Flip it over. All right, so if you're ever given a table and you want to draw a mapping diagram can be used to determine if a relation is a function. In mapping diagram or table, each x value will be paired with only one y value. A y value may be paired with more than one x value, but the relation will still be a function. So if we look down here, we got 1 goes to 0, 5 goes to -4, 3 goes to 6, 5 goes to, -2 goes to 3. This is a function because every x has only one y. Now let's look over here. I've got -1 to -2, 3 to -2. Uh-oh, 3 also goes to 5, so this cannot be a function. All right, I would like you to try out 12, 13, 14, and 15, and then check it back here in a second. So I'm going to pause now. All right, so when I'm looking at this, number 12 is a function because there is only one arrow leaving each number. Number 13 is a function because none of our x values repeat. 14 is not a function because 4 repeats. And 15 is a function because none of our x values repeat. So, it is a one-to-one function when every element of the range of the function, that got blurry, corresponds to exactly one element of the domain. Y equals f of x if it passes the vertical line test. I am not sure what that next blanks are supposed to say, so I'm just not going to do them. Scribble. All right. I want you to try these next 4. Label if it's a function or not. Label if it's a one-to-one or not. One-to-one meaning there is only one x value for every y value. All right. Pause and check. All right, so this one is a one-to-one because each domain goes to one range. This is a one-to-one because each one, it passes the vertical line test, so it is a function. And then every single number has its own, every domain has its own range. Our table here, 1, 2, 3, 4, 5, 8, 11, 14, nothing repeats, thus it is a one-to-one and a function. Down here, it's a function because we have 1, -2, 3, and -5. However, our domains repeat, which means it is not one-to-one. Over here, we've got our it's called a parabola, but on this graph, we'll see it does pass the vertical line test, but the horizontal line test, that's what it was supposed to be. The horizontal line test, it does not pass, which means that it is not one-to-one. Over here, we can see that each domain does not have its own range. Thus, yes, it is a function, but A goes to 2 and C also goes to 2, means it cannot be one-to-one. All right, we're not going to do number 22, but I think you guys have got the gist of this. Put this in a safe spot. Make sure that you don't lose it, and I'll see you soon. Bye, guys.